when you go home to do homework. I will not be there when you leave this classroom to help you. I will not be there when you go off to college. You got to learn how to talk with people to learn. You got to learn how to articulate your ideas and to think. But you also have to learn how to advocate for your own learning. Meaning, I'm going to make sure that I talk to someone to learn. And I will come and help your group if your group has been talking. I will come and help you if you have talked to everyone in your group and you still don't understand it. I am not going to come by and help you if you're just going to monopolize my time when there are other groups that need to talk with me. Is that clear?
Yes.
Okay. Remember that we had the statement that everybody deserves to learn, correct? Yes. But that does not mean that I'm going to sit down and baby you while I ignore the rest of the class. You have a group of 3 or 4 of you together, and in every group that I stopped at, there was at least one person who had an idea for how to solve that equation or solve that problem. Which means that every single one of you had someone to talk to. You may not have been able to perfectly explain it, but you at least had an idea of what was happening. You got to make sure that you are being personally responsible for your learning. And I have already heard this from several students. Brandon, I need your attention. I know that you already think, not all of you, but I know a handful of you already think that you're bad at math. That's not true. That is a lie that you have believed because that you have struggled with math in the past. Or because your parents have told you that you're bad at math. Or because your teachers have told you you're bad at math. Or because your friends have told you you're bad at math. There are people who are better at math naturally, but that does not mean you're bad. Hard work pays off. And if you want to, you can always improve your understanding. Caitlin, it's not funny what I'm saying right now. This is serious. You specifically, I wasn't going to call you out, but you specifically need to put in a little bit more work. And I can already tell that you're just like, I don't want to do this because it's boring or it's useless or it's whatever. No, if you're good at something, you enjoy it. And every single one of you can be good at math if you put in the work. It feels good to do something hard and to accomplish it and to be successful. And if you work for me, you can be successful. It's your choice though. Let's start going over the problems that were on, the questions that were on here. So, we need to be clear about this. Let's see, 2.1. So Sarah ordered flowers from an online florist that sells flowers by the dozen, right? 12 flowers. So, Jordan, I know that you struggle with explaining this equation, but I saw that you developed this equation very quickly. What was the equation that you wrote for this problem?
12 times 3 plus 10 equals 46.
Did you know it was 3 originally, though? Because that's not what you originally wrote down on the equation. It's 12 times what?
3.
Times what?
3.
Does anyone else know what I'm trying to get him to tell me? Kelsey? X. Remember, Jordan, you eventually figured out that it was 3, but was there the number 3 anywhere in this problem? No. Because it asked the question, how many dozens of flowers did she order? If we don't know what something is, we're going to use a what?
It's.
Is it always an X?
No.
Just a variable, right? There are lots of variables that you can use out there. But we don't know what it is, so we're going to use a variable. So 12x, right? And as long as you make an order, Claire, how many extra flowers are you going to get as long as you make an order? 10. Notice how it has this word additional here. So what are we going to do? Add 10. What comes next? Equals 46. If we put together all the flowers together, we're going to get that 46. Now, I want to pause, and I do want to point this out. Am I going over this with the whole class? Yes. Am I going to support the whole class in learning? Yes. Hey, group 3, are all of us paying attention? Pay attention. I'm going to support you in learning. I'm going to come in at the end and have a whole class discussion every single time because I know that at times we struggle. We should have had this conversation 20 to 25 minutes ago. However, I had to keep dealing with people not trying. If you're trying, we can get to these conversations quicker and we can address some issues that I see all the way through. You got to work for it though. And then I'm going to come in at the end and support you. But you're going to learn way more out of it when you have struggled with it. Notice how I didn't say just work through it. Struggled with it within your groups, and then we have a whole class discussion. Remember the 1 to 100 task? When we passed the paper around, and you had to circle numbers 1 through 100? Did you know what the pattern was to start? No. You worked on it. You did the thing that I asked you to do. Then you talked about it. You mean like I keep asking you to talk within your groups? And then when you talked about it within your groups, did you figure out the pattern for the 1 to 100 task? Yes. And then you did it one more time, and then we had a whole class discussion about it? That's what we're going to do every single time. I need you to problem solve and think first, and then learn out of that. Is that clear? Okay. But I need you to actively try the whole time. If you're flying through it or figuring stuff out, you got to remember, you're not just responsible for your own learning, you're responsible for everyone in your group's learning. Take care of your group. Take care of your immediate family that's right around you in mathematics. Your mathematical family. Stop making it weird. Alright? So, 12x plus 10 is equal to 46. Now, once again, we need to be clear about what x represents. When you write an equation, you got to define that variable. What do we mean by x here? The variable should never be confusing.
Unknown number of dozens that she bought.
Where did you get the unknown number of dozens she bought?
Out of my head.
No.
It's on the paper.
Where on the paper?
No.
On the question.
On the question. We have all this information, right? What's the question? How many dozens of flowers did she order? I don't know how many dozens. That's my x, my variable. Notice I'm defining it, but I'm also going to make a note here. This is the question. If I know what the question is, I know what my variable is. Now, I want to jump to the reflection questions because these are the most important. Actually, is there anything else? What comes next? Actually, let's go ahead and talk about number 6 really quickly because that one is a good question. When I look at this equation and I think about the context of the problem, what kind of numbers would never make sense if I'm trying to find dozens of flowers ordered? Zaria? Would it ever make sense to have a negative number of flowers? Or dozens? No, you don't want to owe people flowers. That's literally what that would mean. So, yeah. Can't have a what? Right. You wouldn't have anything if you have a negative number of flowers. So, those are things that we want to think through and be aware of and make sense of before we even start to try to answer the questions. However, right, so number 6, we would never have any negatives. What value do I need for x so that this false becomes true? 3. All you had to do is play around with it, move the cursor. Hey, x is 3. That statement is now true. And what is most important to recognize here is, what are the values for the left-hand side and the right-hand side of the equation? They're both 46. Hey, is 46 equal to 46? Yeah. Okay, so the number 3 is making this equation what? Equal, so it is true. Earlier on the front side of the paper, the value x equals 6 made that equation what? True as well. So when we look down at these reflection questions, Number 2 specifically. So look at the very bottom, look at the reflection question. The reflection question says, what is the value, or what is the solution to an equation?
Something that makes
The solution to an equation is the value that makes a mathematical equation true.
Okay, so a mathematical equation. We're going to work on that language just a hair, but think about what she just said. She said the solution is a value that makes a mathematical equation true. Did we stop every time that equation was true?
Nope.
Did you keep moving the point around? Not really. We wanted to know what makes the equation true. So when we look at the reflection, you should have this down. So reflection number 2. So here's the only thing I will modify about what you said. This is the value, or let's say the solution. The solution is. Sorry. Just trying to make this the right wording. Solutions are value or values, right? You can actually have multiple solutions in certain cases. Solutions are value or values that make mathematical statements true. The really important part is this true. However, the reason why I say mathematical statements is this. Are there any other type of mathematical statements other than equations? That's expressions. Inequalities, right? An inequality, for example, 3x is greater than 9. Is that a mathematical statement? Yes. 3x is greater than 9. That's a statement. Can I find a solution for this? Well, let's say x is equal to 4. Would 4 be a solution to this inequality?
Yes.
Because if I substitute it in, what's 3 times 4?
I mean, no.
12. So why is 4 a solution?
Because it makes the statement true.
Does it make the statement true?
Yes.
Yes. Okay. So this is why I wouldn't just say it's values that make an equation true. It's just any mathematical statement. Does that make sense?
Yes.
Whether it's an equation, whether it's an inequality, or anything else like that, a solution is a value that makes an equation or an inequality true. Please hear me very clearly on this. I will just correct you on it, but I need you to start remembering a solution is not an answer. Your answer can be wrong. The solution is always the value or values that make an equation true. That's the only thing that a solution means in math. It does not mean anything else. Every time you hear the word solution come out of my mouth, does it make the mathematical statement true? We good with that idea? The second most fundamental thing that we need to get out of this task is the first question. What does the multiplication in an algebraic expression represent? Say that one more time. Repeated addition. It does not matter how complicated things get. This multiplication right here tells me one thing, that I am repeatedly adding. So under reflection question number 1, we should make the statement that multiplication is indicating repeated addition. Y'all, we still have like 10 minutes left. We should keep our stuff out. We still got stuff to learn. Thank you, sir. And this is a fundamental idea that a lot of people miss, but is actually super, super important. Have y'all done, I know y'all combine like terms in certain cases, but have you done anything like this before?
Where?
2x squared plus x?
Yeah.
Maybe some of us?
Some, yeah.
Okay? So let me ask this. If I were to put, well, let's not make it quite that bad. If I were to put plus 3x squared there, are there any terms here that I could add together? So I'm going to add all three of these?
No.
No, just the first and the last.
Just the first and the last?
No, just kidding, all three of them.
We're not fully sure is what it sounds like.
Because you kidding.
But they all have x's. Which one are like terms?
The ones with it.
All of them, just the first and
So I would add, so look, but this is the thing, we're a little split here. I hear some people saying that all three of these are like terms. And I hear Kelsey in the back is pretty adamant that only the first and the last are like terms.
Because
The second one doesn't have
because the one in the
square.
middle doesn't have a number.
The second one doesn't have an exponent, a square there. Okay, but I mean, they do still have, they all have x's. Okay? Here's an easy way to settle the debate. 2x squared, what does that really mean?
It means that times itself.
Times two.
Yeah.
Two times.
Multiplication is what? Repeating addition. How many x squareds am I adding right now? So you're telling me that that's x squared plus x squared?
Huh?
No, it's X,
What is
X.
Wait, what is multiplication?
Repeating addition.
So I am adding x squared
Yeah, you're,
twice.
So you can add all three.
Not quite. We good with the fact that that is x squared plus x squared.
yeah.
Okay? That's 1x. That's it. Right here, what do I have?
X, yeah, 3X squared.
3x squared is what am I doing with 3x squareds? I'm adding all three, right? Literally, these are exactly the same, correct?
Yes.
Is x the same as x squared?
No.
So can I add x and x squared?
No.
No.
Nah.
This is why it's important to understand what multiplication actually is. If I understand that that multiplication is repeated addition, well then here I have 2x squareds being added. Here I have 3x squareds being added. Hey, if I have 2 and then I have 3 more, how many do I have? 5.
So basically.
But, can I add an x to an x squared?
Yeah.
Teachers, please excuse
No, they're not the
interrupting.
same.
There are no announcements,
Right?
but
Look.
we need these.
If I do 3 squared,
17
plus
of those
3, are-
students
is 3
to come
squared
down
the
to
same as 3?
office. Emma Stidham, Kira Little, Peyton
No,
Fladsall,
what is 3
Lauren
squared?
Hubbard, Joshua Shelton,
No, 3 squared is
Reverend
9.
Smith,
But are 3
Tyler
squared and
Crummy,
3 the same exact
Randy
thing?
O'Field,
So I can't just add them as they are.
Brandon
I can't
Edmonds,
add these as they are.
Gordon Henley, D'Anthony O'Neill, Joshua
Multiplication
Martin, Gabriel
is
Davenport,
repeated
Nakia
addition.
Tyson, and Jackson
Always gonna hold.
Ashton. Thank you.
Okay?
Check those.
I don't think I have any wrap-up questions for you. I meant to. Hold on 1 second. Alright. Really quickly, I need your attention on this. This homework that I have up here, Josh, did they call your name?
Yeah.
Yes.
Okay. This homework I have up here, I do not have for you yet because we did not get far enough along. However, listen very clearly. This lesson 6 homework, which is 5 questions, lesson 7 homework, which is 3 questions, you will be getting on Monday. So when will those homeworks be due?
Thursday.
Thursday.
Oh, they don't have.
If I assign them on Monday, I can't make them due on Monday, they'd be due on Thursday. So you're going to have the week leading up to Thursday to ask questions. But be prepared, you're going to have 8 questions, that's it, due next Thursday. We clear?
Yes, sir.
Okay. We don't have time for the exit poll questions.
I'm sorry.
Can we turn this in?
Hold on to that because you're going to want it for the next couple of lessons. I will collect it soon though.
How you like
Alright, we're going to continue working with equations and inequalities on Monday. Please put the calculators up.
There. Still there.
Put it up there. The bell, this is, I don't think I've ever ended this early before. Grab a seat because we have about 2 or 3 minutes before that bell rings.
Yeah.
Man, I really don't think I've